All right, let's finish up this lesson 1.4. That's why I called it 1.4b, because this is the second part of it. So we left off right before example 4. So let's do example 4. All right, and we're solving. It says solve equations, so it says to solve for this thing. So here it is. Everybody write this down. This is a little bit more complicated than what we did yesterday, because yesterday we just had one variable. This problem has what, 3 variables in it? But we're only solving for one of the variables. I can't say just solve. This group in the corner will definitely be broken up next week, okay, just so you know, because every time I try to talk, I hear rumbling. I don't want to hear rumbling, all right? You think you're talking to yourselves quietly, but it bothers me, all right? If it bothers me, then I put a stop to it, all right? That's how it works. So here we go. I can't just say solve, because I don't know what to solve for. What do I solve for? Do I solve for x, b, or a? Don't know. So they tell you, all right? They say solve for x. And that's not unusual, right? They always want you to find x, but they're not always going to do that. Now, this is really important to be able to do stuff like this with many different variables, because when you take like a physics class, I don't know much about chemistry, but maybe same thing in chemistry. I definitely know physics. I've taught physics for a bunch of years. But you're going to have these equations with all these different variables. You might have 3 or 4 different variables in there, and you're going to have to solve for one of the variables. And so what we're doing right now prepares you to be able to do something like that. All right? Simone, that problem that you showed me is very, very similar to what maybe a physics equation would look like, right? It's got all those weird variables and Greek letters and all that kind of stuff. But that's what this kind of stuff is going to do. All right, stuff we did yesterday was baby stuff. It was no big deal. But this stuff, you know, it makes you think a little bit more. So we're solving for x. We're going to get x on the same side. Well, I've already got an x right here, and I've got an x here. So what do I want to do with this x? Move it where? To the left. To the left. All right, I want to move it to the left. All right, put it on the left-hand side. So I already got a 7x right there. Let's take this and move it to the left-hand side. How do I move that whole thing? Not just the x, but the whole thing. I add it. That's right. I add an ax. All right, that way it goes away. We're good so far? Now, in the same step, okay, you don't have to write everything else down. In the same step, let's get rid of this, because I want the x by itself, so I definitely want to get rid of that. So how do I get rid of that? Subtract it. So what am I going to have? I'm going to have 5b, what? Minus 18b. Everybody see that? Okay. And then let's do this. I'll tell you what, let's do the easy part first, then I'll do the part that, it's not really that hard. It's an Algebra 1 topic, but it's one that you may have forgotten. I don't know. So let's do this first. What's this going to give you? 5b minus 18b. Negative 13b. Good. Now let's talk about this right here. I just want one x, don't I? All right, or an x there. It could have a number out in front of it, but I want an x by itself. So what I'm going to do, this has an x and this has an x. Give me a word. Give me a math word. Now, they're not like terms, because this has a 7 and that's an a. You don't know what that is, so you can't add those together. It's kind of distributed, but kind of the other way. What is it? It's kind of divide, but there's a good math word. It's a good algebra word that you do a lot. Starts with an F. Factor. That's right. We're going to factor, okay? We're going to factor out an x. It's basically the backwards distributive property, okay? So, for instance, if I had x times a plus b, watch. What would you do? You would go xa, or ax, right, plus xb, or what? bx. What we're doing is we're starting with this, and we're going to end up with that. So we're taking out a common factor. This is scary. Doesn't look like factoring is... Yeah, you should have done it in Algebra 1. Did you guys do factoring in Algebra 1? You don't remember? It's 2 years ago? Okay. Good. Right, but you remember the topic, the word? You remember the word? Okay, at least you remember the word. That's good. All right, so That's what we're doing right here. So what do we have in common? An x. And so I put a parentheses, and I'm gonna do the opposite of multiplying, right? And so somebody said division. I was like, well, kind of. So what are you going to do? You're going to take an x out of this. What are you left with? A 7. You're going to take an x out of this, and you're left with plus a. Everybody see that? You say you do or don't? You do? Okay, good. Yeah. We're going to do... Now, when this course is complete and over, and somebody talks about factoring, you're like, oh, what? We didn't do factoring. Well, you weren't here then, because we're going to do a ton of factoring in here, all right? But this is about the easiest kind of factoring you're going to do. Now, one more step and you're basically done. I want to get x by itself. So what do I want to get rid of? That's 7 plus a. And what is that 7 plus a doing to that x? It's being multiplied. So how do you get rid of it? Divide. So I'm not going to show it. Is that all right with you? We're in Algebra 2. We don't have to show that part. We know it's going to cancel out. So I'm going to get x equals. Now, if I divide this by 7 plus a, what am I going to have to do over here? I'm going to have to divide that by same thing, 7 plus a. And that is almost your answer. I'll tell you why almost. When you get more into algebra, like I teach a pre-calc class after this is one thing we've been harping on a lot since school started, is the denominator. Now, look, in order to get an actual number for x, we'd have to know what a is equal to, and we have to know what b is equal to. Agreed with that? All right. Can a be equal to any number in the world?
Except for x and b.
No. Now, when I pause like that, what do you think I mean? So no, right. A cannot be any number in the world in this situation right here. Why not? Okay, it's in the denominator. You're getting there. Well, there's no exponents here. Think about it. What can you not have? You can't have 0 in the denominator, correct? All right. Guys, are you watching? You talking about this problem right here? Okay. Well, it's not negative reciprocal, but this right there cannot be 0. Would you agree? Because you can't divide by 0. Because what's 3 divided by 0? It's not 0. It's undefined, right? It doesn't exist. All right? So it's undefined. It doesn't exist. So this cannot be 0. Does that mean that a cannot be 0? No, a can be 0 because what's 7 plus 0? 7. Am I allowed to have a 7 in the denominator? Yeah, that's fine. All right? It makes it kind of ugly, but you can have it and it can exist, sure. But what can a not be equal to? So let's write it a plus 7. Is that all right? 7 plus a plus 7, same thing. So this cannot be equal to 0. So what can a not equal? Negative 7, that's right. So I subtract 7 from both sides, so a cannot be equal to negative 7. I don't think on these problems I'm going to ask you to do that, okay? But eventually they will. Like in my pre-calc class, that's the big part of what we're trying to teach. They call it the domain. The domain are all the values that can be equal to. Well, a can be everything except for one thing. What's the one thing a cannot equal? It can't be negative 7. What if it was negative 7? Then the denominator would be 0. And then the whole thing would be undefined, and there would be no answer for x, right? So a and b can be anything. What about the top? Can b be anything? Yeah, it could be any number in the world, okay? It could be a fraction, a decimal, positive, negative. It doesn't make it. It could be 0, right? Because if it was 0, 0 divided by anything is what? 0, because 0 divided by 3 is 0. And that is something, even though you fought me on that. 0 is something, all right? It's a number. Okay, you can add it, you can subtract it. It does represent something. It's on the number line. Would you agree? You can't disagree with that. It is on the number line, so it is a number. So that's what they did here. It's kind of weird, but I'm fine. I am perfectly fine if you leave your answer like that. I'll put a check mark next to it that you got it right. I'm not going to require you to do this, but you might see, like if you flip back in the back and you see the answers, you might see that. And you're like, oh, okay, that's what Mr. Hammer was talking about, the domain, and it can't be equal to this, that kind of stuff. Does that make sense? All right. In Algebra 1, we would have never mentioned that, probably. All right. Let's do one more example. And then we'll be finished with this. Example 5. This one says solve, but they tell you what to solve for because they got several, solve for A. All right, so that's what we're going to do. Now, we got fractions. Well, we did a fraction yesterday. Do you remember that?
Yeah.
But this time we got a bunch of letters. In fact, we got more letters than we have numbers in this. There's your number. Well, technically, they're all numbers too, aren't they? Yeah, they're variables. They could stand for any number. Well, except for C. What can C not be?
Yeah.
Right, C can't be 0, all right?
What about B? Because B is only not.
Yeah, B can't be 0 either, right? So B cannot be 0 as well. So let's just write that down so we remember. So B can't equal 0 and C can't equal 0. All right, we good? All right, what are we going to do? We got to solve for A. I'll tell you what. Let's do this just to make it a little easier for you. I don't know if this helps or not, but I'll put all the A's in red just so they pop out a little bit. Pink, well, it's too late. Next one. All right, those are all the A's, right? So I want to get A by itself. But before I even think about getting A by itself, what don't I like about this particular problem? The fractions, okay? We mentioned this yesterday. I kind of started off the same exact way. I didn't like the fractions. What really makes a fraction? The denominator makes it to be a fraction, doesn't it? Okay, so I want to get rid of these denominators. So how do I get rid of the denominators? Let's go with this yellow color. What did we do yesterday? Do you remember? Multiply everything by BC. In this case, it's BC, the common denominator. That's right. So let's multiply everything by the common denominator. Why the common denominator? So that the denominators cancel out. Because remember, each one of these denominators will divide evenly into the thing that we're multiplying. All right? And so I want the B to cancel out. I want the C to cancel out. So that means I multiply everything by BC. And I'm going to multiply this by BC. And I'm going to multiply this by BC. Let's put that in parentheses as well. Everybody with me? Now, why did I do that? I did that so that the denominators cancel out. So watch what happens. Look, I got a BC on top, or a B on top and a B on the bottom. What happens? They cancel. All right? In this fraction right here, I got a C on the bottom and a C on the top. The C's cancel. So now I don't have any denominators. Now I got rid of my fractions. Life's much better now. Okay? But we got to clean it up. Let's clean this up, make it look kind of nice. What's left on top? If you wanted to, you could distribute right now, but I'm going to just write it down just so everybody can see the steps, okay? Once you get good at this, then go ahead and just do that in your head right now. But so this is going to be what? A plus C equals, and what's this going to be? DBC minus all this. We've got a B on the outside. I'll put it on the left this time. So it's B times everything in here, right? A minus 2B. So that looks a lot more manageable, would you agree, than what we started before? Yeah, I think so. Again, what are we trying to solve for here? A. So what are we going to do? What are we going to do with that C? Distribute. Yep. So I'm gonna put the A first. Is that all right? C-A-A-C. I just like the alphabetical order. Plus what? C squared. Yep. C times C equals DB. Let's put this in alphabetical order too. Is that all right? BCD. It doesn't matter. Just a little, what do you call it? OCD or something like that. I just like it in order. Okay. Minus. Now, you got to be careful. Here we go. We're going to take this and do what to it? Good math word. What is it? Distribute. Right. We're going to distribute. All right. So let's do that. What is this going to be? Minus what? AB. Look, minus a negative is going to give us plus, and then it's going to be B times 2B, which is what? 2B squared. Okay. That's all we did. We just did couple distributive properties, and that's it. Now, let's see. Are there any like terms I can add together here? Nope. Nope. So now I'm ready to get the A's on the same side. All right. I already got an A on the left side, so let's keep that right there. Let's bring the other A over. So it's right here. So what am I going to do with that? How am I going to take that to the other side? Add it, right. Add it to both sides. And what's going to happen when this adds to the other side? Or to both sides? That's going to cancel out, and I get a plus AB. Good with that? Let's do something else. Let's do it in the same step. I don't need to write everything else down. Let's get rid of this C squared. How do I get rid of the C squared? Subtract it. That's right. So I could put it right here, couldn't I? All right, so let's see what we get. BCD. That canceled out. Plus 2B squared minus C squared. All right. Again, what am I trying to do? What's my ultimate goal here is to get what? A by itself. Solve for A. So I want to get A by itself. I got an A here and an A here. Now, this is what we did on the last example that you guys struggled a little bit with. So now you should see it. So I got an A here and an A here. What am I going to do? Factor. That's the word. Okay, that's what I want you to use. Use the word factor. So I factor out an A. And then what's left? Yeah. Yeah, I'll just go in order. Maybe I'll change it later. I don't know. All right. And then all this, right? All right. I'll just copy and paste so I don't have to write it all. I can do that on this. It's nice. And then one more step and I'm basically finished. Divided by C plus B. So A equals all this again. Okay? And then what? Over. Oops, that's a terrible line. Let's make this a little nicer.
Did the C's cancel out?
No. I'll talk about that in a second. Now you can write C plus B or B plus C. It doesn't matter, really. And I don't even need it in parentheses, tell you the truth. I can just leave it like that. So that right there is the answer. Now the question was, it was a good question, do the C's cancel out? Do the B's cancel out? Can I cancel out this B and this B right here? I can't. Why? Well, it's because this is being added to other stuff. For instance, let me show you a real super basic example. What if I had 2 plus 3 over 3? Can I cancel out the 3's here? No. The only time I can cancel out the 3's is if it was being multiplied. Remember, I cancel them out because I'm doing the opposite, right? Multiplication and division are the opposite. Is addition and division the opposite? No, so I can't cancel them out. Because what would this be? This would be 5 over 3. If I canceled these out, I would get a 2. Is 2 the same thing as 5 over 3? No. So it's the same reason here. This C and this C does not cancel out, all right? Because this is being subtracted, this is being added to something else, all right? So nothing else cancels. There's nothing else I can do. There's nothing in common with all three of those. I can't factor out anything. I can't add any like terms. That's it. That's my answer. I'm done. Boom. Yes, sir. Right out of pass. Now, that was a little involved, right? A little bit. Did you write where you're going and stuff? Okay. So make sure, make sure that you are good with something like this. This is I guess you might have done this in Algebra 1. I can't remember. It might have been a lot later on in geometry. Yeah. Yeah, even like, here, we did something today in my geometry class that's similar. It's not near as involved, all right, but it's similar to it. So watch. What if I said circumference? Do you remember what circumference is equal to? 2 pi r. So what if I ask you to solve for r? Well, you get r by itself. So you divide by 2 pi. So r is what? C over 2 pi. You see that? All right, so even though they're just letters, we could still do algebra with just a bunch of letters, and we don't have to have numbers, all right? Because the letters represent numbers. So we do the same thing. The same rules apply. They just happen to be numbers that we just don't know what they're equal to. That's all it is. So they still are numbers, all right? And there's probably other examples in geometry where you had to do stuff very similar to this. Probably not near as involved, I doubt. I mean, you didn't do anything that involved in geometry, did you? As far as algebra?
This one paper where it was just all letters.
Yeah. So yeah, there's situations like that. All right. But there you go. In physics, I talked about that earlier today. In physics, that's where my mind goes right away. And I'm sure in chemistry too. Talk to Mr. Cheadle about it. I'm sure in chemistry there's situations like that where you do algebra with basically all letters, right? So you have these big long equations and you got to solve for something that's like somewhere in the middle, right? So instead of just plugging all the numbers in, you solve for that letter first, and then at the end, then you can plug everything in. So let's say this isn't any kind of equation. This is just a made up, formula, okay, right here. But let's say these represented something, and B was equal to something. We knew it was equal to 17 meters, right? C was equal to something. D was equal to something. So now, once we know what they're equal to, we can just all plug it into this, and bam, you got A by itself. All right, and if you wanted to solve for A, that's what you would do. You just solve for A. You do all this mess, then you can chuck them in there. It'd be a lot easier, I think, doing it like this than chucking the numbers in right here and then doing all the math with a bunch of numbers. So this way, you've established a formula. Again, this isn't really a formula. This is just a made-up little math problem. All right, but in physics, you'll have formulas that you want to know and you want to memorize, and that's the kind of stuff that we do. So this kind of stuff is super helpful. Let me give you your homework, and I'll let you get started on it. We still got what did I say, 10 after? So you got 15 minutes. That's pretty good. Oh, it's 5 after, sorry. Okay, so you got 10 minutes. All right, so section 1-4. You probably have it already, but I'm going to write it down anyway. Did I write it yesterday as well?
Yeah, I think so.
1 to 39 odds?
Yeah, I think.
Maybe I said to start it and then tomorrow I'll finish it off or something like that. But there it is. So that'll be due on Monday. Okay, so due Monday. Everybody good? All right.